Hey, seventh graders, it's me, Mr. Stark. We're in our room here, first Monday, the week of October 26th through the 30th, and I'm setting up some videos for the week about things that you'll be doing. So one of the things that we are doing, I had you finish up your potato lab data on Monday and Tuesday. We are going to start and switch gears to the scientific method. Do a little short unit on that, and then with a bunch of labs and things that will allow you to practice using your scientific method information. So I just put together some notes for you on the scientific method. Um, the scientific method is a process that's used to investigate scientific problems. One of the things about scientific method is that it allows for repeatability. So when you do something and you come up and you create something or you discover something, if you follow the scientific method, you'll have the ability to hopefully repeat that and not have to redo all your hard work over again, because you've already put the work in of paying attention to following a certain process to solve that problem. Okay, so in the first thing that you do is you discover a problem. There's a situation. There's something that's happening here. Um, we notice, you hear in the news there was all the time in the summer you hear about people forgetting their dog or something in the car, and how warm the car gets in the summer when it's just sitting there in the parking lot. So the problem might be how does paint color affect affect the rate at which the temperature in the car raises? Um, so that's the question. Now you would maybe then take and figure out or formulate a hypothesis or an educated guess of what you think will happen. You probably learned in elementary school that darker colors absorb more and white colors reflect. So if you've ever gone outside with a black t-shirt in the hot part of the day in the summer, you get a little bit warmer because that your t-shirt is absorbing all the sunlight. But if you go outside and you have a white t-shirt on, the white color will reflect all the wavelengths of light, and so therefore black absorbs color and white reflects color or light, and therefore you might hypothesize that the black car would absorb the heat more and the temperature would raise much more quickly inside a black colored car. That would be our hypothesis. Then we need to develop a little test, come up with a list of materials and what you'd need to be able to test this to prove that the black colored car will warm up faster than a white colored car. So first of all, the things you need to do your test. I said that we would need a light and a dark colored car, thermometers, stopwatches, and a location to test the rate at which the temperature increases inside the car. The location, the cars to be side by side. The thermometers will be placed in the same place in the car in both cars. And you'd start the stopwatches at the same time. So we've got our list of things that we need. Then we go develop a procedure. These are the steps. You produce that, and you must test only one condition at a time. So you can't park one car at school and one at Coburn's, and the thermometer on the floor in the front seat and the thermometer on the floor in the back seat. There's too many things that are different about these two tests to determine whether one condition made a difference or not. And that condition, in this case, should be the color of the car. Everything else should be identical. So, procedure. Park the cars of different colors side by side. Place the thermometers in the same location in the car and monitor and record the temperatures inside the car at the same time. Then you'll collect your data. You'll watch your temperature. At 1 minute, this is what happened. 2 minutes, this is what happens. 3 minutes, this is what happens. Okay, and you record all that. Okay. Other parts to the scientific method are the controls and variables. A variable is something that will change the event. Okay. So here we are testing the dark colored car and the light colored car, that is going to change the event. So our variable can only be, in this situation, the color of the car. The independent variable is the one that you have control over. So we are controlling the color of the car to see if it makes a difference. The dependent variable is what you are measuring to see if it was affected. So what's the dependent variable? It's the temperature inside the car. The control is something that's kept the same when you're testing. So the make, the model, the location, the thermometer, the stopwatches, everything else is identical. Leave nothing else to chance. Your results, that is all the stuff that you collect and what information you draw from that. Does the black car get hotter than the light colored car? Did the results support your hypothesis? Finally, you draw a conclusion, an opinion about your original hypothesis. Was your hypothesis right or wrong? If yes, you should retest it and see if you get similar results. If you continually do that over and over and over and get the same similar results, you can say that you have a theory about the color of the car affecting the temperature inside the car. If not, you need to evaluate your hypothesis, change it, and test it again in another manner. Okay. So two examples of conclusions might be: the data showed that the temps inside the darker car increased at a faster rate, or data showed the temps inside the lighter car increased at a slower rate. These are the notes for scientific method. All of these and these bolded things, these are all parts of the scientific method. You should become familiar with each of them. I also posted on Google Classroom a pretest. I'd like you to use these notes to complete the pretest. Fill it in. It's a matching exercise. And go ahead and submit that to Google Classroom by the 28th, Wednesday the 28th. Thanks. Have a great day. See you tomorrow.